Hi you guys, so today I will be showing you guys how to solve limits using algebra. At this point you should already have a fair understanding of what a limit is. This is actually not a hard thing to do. The first thing we have to do to solve a problem is to use direct substitution. So our first example is going to be the limit of 3x minus 5 as x approaches 2. So we have to remember to carry the notation, and our first step is to plug in the 2 where our x is. Then we're gonna carry our notation, and we're gonna multiply 3 times 2, which is 6, minus 5, and then finally we're just gonna solve, and as the limit of 3x minus 5 as x approaches 2 is going to be 1. Now for our second example, the problem is the limit of 4x minus 15 as x approaches 5. And we're going to do the same thing that we did with the first example. We're going to plug in our 5's wherever we see our x's. And then finally, we're just going to do some basic arithmetic and multiply out 4 times 5, which gives us 20 minus 15. And that gives us our answer. The limit of 4x minus 15 as x approaches 5 is 5. So the second way of solving limits algebraically is by factoring out and canceling anything that you possibly can. When using substitution, it will not always work if the answer turns out to be indeterminate. And indeterminate means just that your answer is 0 over 0. Then what you would want to do is factor out the problem and cancel out anything that you possibly can, because that will make solving it much easier. So our next problem is going to be the limit of x squared plus 2x minus 24 over x minus 4 as x approaches 4. And right now I'm going to show you that just by simply substituting, which was the first method of solving limits algebraically, and how that's going to give us 0 over 0, which is undeterminate, and why it doesn't work. So you're going to do what we did with the first method, which is plugging in all your 4's for the x's, and then we're going to solve. So 4 squared gives us 16 plus 8 minus 24 all over 4 minus 4. And when we solve that, it's going to give us 24 minus 24 all over 4 minus 4. And when we solve that, it's simply going to give us 0 over 0, which is indeterminate, and that is not good. So the proper way of solving this problem using factoring and canceling is we're going to rewrite the problem. The limit of x squared plus 2x minus 24 over x minus 4 is to simply butt cheek or factor out the numerator. Now when we factor out the numerator, that's going to give us x plus 6 times x minus 4 over x minus 4. And as you guys can see, there's an x minus 4 on both numerator and denominator, and we can easily cross that out, leaving us the limit of x plus 6 over 1 as x approaches 4, and we plug in the 4 where our x was, which leaves us 4 plus 6 over 1, giving us 10. So our next example is going to be the limit of sine 7x over x as x approaches 0. And once again, I'm going to show you how if we just plug in the 0 using the substitution method, we're going to end up getting 0 over 0, which is indeterminate, and we do not want that. So moving on to our third example, which is the limit of sine 7x over x as x approaches 0. And what we want to do first is multiply a 7 to both the numerator and the denominator. And when we do that, that's going to give us the limit of 7 sine 7x over 7x as x approaches 0. And because we did that, we're now able to pull out a 7 from the numerator. So we're going to multiply 7 times the limit of sine 7x over 7x as x approaches 0. And for this specific problem, what we want to do is substitute the 7x with a different variable, for instance z, and that's just going to simply leave us with a 1. So 7 times 1 equals 7, and that's the answer to this problem. The last way to solve limits using algebra is by conjugating. Conjugating is the same expression with the opposite signs between terms. For example, there is 3 plus the radical of x and 3 minus radical of x. However, this is only used when there is a radical. This matters because you can quickly use the difference of squares to multiply them out and eliminate the radical sign. So first, what we're going to do with our example problem, the limit of the square root of x plus 1 minus 1 over x as x approaches 0 is to multiply by its conjugate on both the numerator and denominator, which is simply the square root of x plus 1 plus 1 instead of minus 1. And we're just going to multiply each term, and that's going to end up giving us the limit of the square root of x plus 1 squared minus 1 squared all over x times the square root of x plus 1 plus 1. And it's going to be important that you put parentheses around the 1 so you don't get confused later on with your positive and negative signs. And when we have the square root of x plus 1 squared, they cancel each other out, leaving us with x plus 1 minus 1 squared, which is simply 1, over x times the radical of x plus 1 plus 1. And since we have a plus 1 and minus 1, we can cancel each other out, leaving us with x over x times the square root of x plus 1 plus 1. And as you can see, we can once again cross out the x's to simplify it, and that's just going to leave us with the limit of 1, because remember there's an invisible 1 when we cross out the x. So it's going to be the limit of 1 over the square root of x plus 1 as x approaches 0. And now what we want to do is substitute, which is the first method. So we're going to plug in our 0 wherever we see an x. So we're going to get 1 over the square root of 0 plus 1 plus 1. And 0 plus 1, the square root of it is simply just 1. So now we are left with a simple equation, which is 1 over 1 plus 1, and our answer is 1 over 2.